think about that by thinking about the sine curve and the cosine curve. So knowing that it's sine over cosine, write down the domain of tangent. And you can look here and think about the secant graph. Hang on. Emma, you got a notion?
I don't think the name.
Uh-huh.
Would it just be all round number? Or
What do we need to worry about?
Zeros.
Zeros on the cosine curve, because that's going to give us a zero denominator, right? So what do we have to ditch? Alex?
It's the same as the secant domain because it's 0 at the half pies. So
The odd half pies.
the odd half, right? The odd half pies.
Okay. All right, are we happy with that? Yes? No? The question is, when is cosine equal to 0? Cosine's equal to 0 at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. So the odd half pies. So I'm going to have to throw out, so the reals, x not equal to 2k plus 1 over 2 times pi. So at the half pies, I know I'm going to have asymptotes because that's where the cosine curve is 0. What's another easy point to get? Okay, hold on a second, I'll give everybody a chance. Hank?
I guess when the sine curve's 0, it's 0.
Sure, because if the numerator of a fraction is 0, the whole fraction is 0. And when the sine curve is 0, the cosine curve is 1, so I would have 0 over 1. And when I get to pi, I would have 0 on the sine curve, neg 1 on the cosine curve. So where are the zeros going to be? At
intervals of pi.
At intervals of pi, right. So all of the k pi's. Okay, now this is not the best graph in the world, especially I started losing it over here. But notice that there's a place where the cosine curve crosses the sine curve. What would that mean?
It's 1.
Who's it?
The 1 at that x value, the y will be 1.
On which function?
The tangent.
On the tangent function. The sine and cosine curves would be the same, so the tangent function would be 1. It turns out that happens at pi over 4. Now, we don't have a reason to know that yet. I'm going to be polite and believe me. Okay? So, sine and cosine are equal, so at pi over 4, tangent is 1. And if I did this, there's a place over here, this is pi over two, negative pi over two, where however high the cosine curve is, the sine curve is that low, except it's got the opposite SIGN. So this is, maybe this is positive 0.7 and this one is negative 0.7 for the y's. So what would the fraction of those two be? Negative 1. So there's a place over here at negative pi over 4 where the tangent curve is negative 1. Now when I get close to pi over 2, the sine curve is getting close to 1, so the numerator is close to 1. The denominator is getting close to 0. So I have something like 0.9 over 0.1. And I have 0.99 over 0.01. What's happening?
Flying to infinity.
Flying to infinity. And flying to negative infinity. And then it just happens again. And that's your tangent graph. Go.
Should it be 3 pi over 2 or is it?
Oh my gosh, yes. Thank you. Okay. So this is also a toolkit function. It's another one we know. These 2 points are important. The pi over 4 comma 1 and negative pi over 4 negative 1, because that helps us when we do vertical stretches. So we need those points. Okay. So, yes ma'am.
So, just like when it's pi over 4, they're at like the same height, like, and I think each other, that's gonna be 1, so do we know that when it's negative pi over 4 and negative 1, is that the point?
Yes, because this guy, the pink one is the same height above the x-axis as the white one is below the x-axis. So the heights are the same, they have opposite SIGNs. Go.
So at like 3/4 pi, that's negative 1, and then at 1 1/4 pi, that's 1.
That's exactly right.
Okay.
Yep. So that's what Emma just said. This one happens then at. Okay, we wrote down the domain. You should write down the range and the period in your notes for homework tonight. And on page 310, you should do number 1, the odds. Number 2, the odds. 5, 7, and 8. And let's see, I'll see you on Thursday.
Pi over 4 in radians is the same as 90 degrees, right?
No, pi over 4 is in radian measure already.
Like, it's pi over 4 is, so it's money